Welcome back to 5.3 Right Triangle Similarity. We're going to start with the definition of geometric mean. It's a special type of average where we multiply the numbers together and then take the square root. For two numbers, cube root for three numbers. So the idea is it's going to look like this, a proportion where the variable repeats in the top left, bottom right. The idea is it's either the extremes or the means. But you'll get x squared equals a times b. Essentially, you just multiplied the numbers together. And then you take the square root of the multiplied numbers. Okay? So geometric mean, 10 times 40 is 400. Then you take the square root, it's 20. 5 times 15 is 75. Then you take the square root, it's the square root of 75. But we want to simplify this. So the biggest perfect square that divides into 75 is 25, 3 times. Square root of 25 is 5, so that becomes outside. 5 square root of 3 is our answer. We're going to use geometric mean in right triangle similarity. First thing you always want to do is redraw the triangles that you see here. There's 3 triangles. There's a small one that's actually on its side. We have to turn it so that the right angle is in the bottom left. And then you got the medium on the right, and then the whole right triangle, the big one. So I'm going to redraw them again where the bottom left is the right angle. So to label this triangle, a small one is x on the bottom and 3 on the side there. The short side is 3. On the medium triangle, the short side is x, the bottom is 9. And on the big triangle, 9 plus 3 is 11. So to write a proportion, you always ignore the triangle that only has one piece of information, and you just write a proportion. 3 is to x is to 9. Cross multiply, notice this is the geometric mean. We get x squared equals 27. Take the square root, we get the square root of 27. Biggest perfect square is 9, 3 times. Square root of 9 is 3, so this is 3 square root of 3, or about 5.2. And again, redraw the 3 triangles. On the small one, the small side is 2, the hypotenuse is x. On the medium, the bottom is 6, because 8 minus 2. But nothing else. And then on the big triangle, the small side is x, and the hypotenuse is 8. Ignore the medium triangle this time to write a proportion. X is to 2 as 8 is to x. We get x squared equals 16, so x equals 4. Okay. Here, redraw the triangles. On the small triangle, our small side is x, but not, and our bottom is 12. On our medium triangle, small side is 12, the bottom is 16. On the big triangle, the hypotenuse is x plus 16. Ignore the big triangle here. X is to 12 as 12 is to 16. What repeats this time is the number, not the variable, but it's fine because we're still doing 12 squared equals 16 times x. 12 squared is 144, divide by 16, we get 9. On this triangle, when we draw our 3, this one kind of gets a little bit weird. The small triangle, the small side is 36, the hypotenuse is 60. The medium triangle, the base is x. And on the large triangle, we have small side is 60, and the hypotenuse is x plus 36. So when we set our proportion, we now have a binomial in it. 36 is to 60, as 60 is to 36 plus x. Notice the 60 repeats. We get 36x plus 1,296 equals 3,600. Subtract 1,296, then divide by 36. We get x equals 64. So there we go. That's all there is to right triangle similarity.